Can a pigment produced by fungi be used to make solar cells? That's the question we set out to explore. Xylindein is a naturally occurring pigment from a wood-staining fungus with unique electronic and photostability properties. If solar cells can be made from it, this could open a new path to truly sustainable bio-based energy technologies. To get started, researchers at Aalborg University expressed the relevant genes and scaled up the microorganisms in a bioreactor to produce sufficient quantities of the pigment. After extraction and purification, we began testing Xylindein as a functional material in organic solar cells, both as a donor and an acceptor. To do this, we formulated 2 separate inks. We carefully weighed out Xylindein and blended it with either a donor or an acceptor using a solvent. The mixtures were stirred under heat to fully dissolve the materials and ensure homogeneous solutions. Once the inks were ready, we prepared to coat. We cut a piece of substrate and placed it on the vacuum chuck, which we activated to secure the substrate. Afterwards, we assembled a slot die head, which we then mounted to a slot die coater. Next, we transferred the finished inks to syringes, which were connected to a syringe pump and mounted to the slot die head. We coated 2 stripes, one for each blend, adjusting speed, gap, and ink flow to optimize the deposition. After cleaning the equipment, we applied a whole transporting layer on top of each active stripe using the same slot die process, slightly offset to maintain layer definition. To complete the device structure, we printed silver electrodes using a flexo roller. The patterned cells were then cut, contacted with copper tape, and sealed carefully with a special resin. Finally, the finished solar cells were tested under a solar simulator, demonstrating that this highly interdisciplinary collaboration between academia and industry can rapidly open new pathways toward a sustainable future. Learn more at infinityPV.com.